Let's take a moment to understand the working of a nuclear reactor. Nuclear reactors are the modern-day devices which are used extensively for generation of power. Earlier, we used coal and other non-renewable sources for the purpose of power generation. But since we are running out of them at a very rapid pace, we need to look at sustainable and possible and eco-friendly way of moving forward. The nuclear reactor consists of three core components: fuel elements, moderator, control rods. Fuel elements consist of cylindrical rods put into bundles. A uranium oxide ceramic is formed into pellets and inserted into zircaloy tubes that are bundled together and contain fissionable nuclei of uranium-235 or uranium-238. The number of rods varies greatly according to the size of the reactor. The fuel elements are placed inside the reactor core. The fuel elements are immersed in water which act as a moderator. Moderator is essential in slowing down the energy in neutrons in nuclear reactors which are produced during the fission process by the fuel elements. Normal or heavy water is generally used as a moderator. Thermal neutrons produce fission reaction with uranium-235, and during this process, new neutrons are given out which have the energy of about 1 MeV or 1 mega electron volts. These new neutrons typically escape from other fission process as they are accompanied by huge energy with them. Here, moderators come into play. Moderators have the capacity to slow down these high-energy neutrons. Water molecules present in the moderator are also instrumental in slowing down further the speed of high-energy neutrons. The new reaction then takes place with the slowed-down neutrons by striking them with fuel elements. A liquid or gas circulating through the core so as to transfer the heat from it. In light water reactors, moderator also functions as a coolant. Usually, a robust steel vessel containing the reactor core and moderator or coolant, but it may be a series of tubes holding the fuel and conveying the coolant through the moderator. Another very important part of the nuclear reactor is the control rods. We would like to have the steady flow of energy from the reaction, isn't it? For that purpose, every single fission reaction leaves spare neutrons which in turn are utilized for more subsequent reactions. The control over the spare neutrons available at any given time, the rate of nuclear chain reaction can be controlled. This control on fission reaction can be maintained using control rods. Control rods work by absorbing the excess or spare neutrons in the moderator to prevent any further fission reactions. These rods are usually made up of boron or cadmium. To increase the rate of reaction, the control rods can be removed by the moderator. A steady output of energy must be maintained by inserting or removing the control rods in the reactor. Apart from the above, three other important core components of a nuclear reactor are as follows: pressure vessel or pressure tubes, pressurizer, steam generator. Now that we have understood the various elements of the nuclear reactor, let us see the entire operations in the nuclear reactor. Nuclear reactor consists of a reactor core, pump, and the heat exchanger. Due to the enormous amount of heat produced and then released during the fission process, surrounding water gets heated up and changes into steam. This steam turns the turbine, thereby starting the generator which produces electricity, lighting up our world.